So the question number 4 says that check whether the first polynomial is a factor of the second polynomial or not. So this particular polynomial is definitely a factor of this polynomial if the remainder after dividing these two polynomials comes out to be is equal to 0. If the remainder is 0, then definitely this is nothing but the factor of this particular polynomial, and if the remainder is not is equal to 0, then both of these are not, or we can say this is not a factor of this particular polynomial. So let's just divide these two polynomials. So first of all, let us suppose I am supposing the solution. Let us suppose we are taking the solution, and I am supposing this particular polynomial as p of x. So p of x is nothing but 2t raised to the power 4 plus 3t cube minus 2t square minus of 9 of t minus of 12, and I am taking the other polynomial as g of x, which is equal to t square minus of 3. As we have the particular polynomials in the variable t, so we cannot represent it as p of x. We have to represent it as p of t, because the variable that we are using over here is nothing but t. Again, we can use the variable as nothing but t. We cannot use it as p of x, because p of x resembles the polynomial in x. We are using the polynomial in t, so hence we can resemble it as p of t and g of t. So let's just divide these two polynomials using the division algorithm. So we have t square minus of 3, and we have the dividend as 2t raised to the power 4 plus 3t cube minus 2t square minus 9t minus of 12. So let's just divide these two particular polynomials. So first of all, we have to divide the very first term of both of these. So when we will divide both of these two terms together, we will get the answer as 2t square. So this is the first term of our quotient. Let's just multiply the quotient or the first term of the quotient with the whole divisor. We will get 2t raised to the power 4 minus 3 plus 2t square minus 6t square. So I'm writing it over here as minus 6t square. So let's just change the signs. So it will be negative, it would be positive. So hence both of these terms get cancelled with each other. We will get 3t cube again plus 6t square minus 2t square. It is plus 4t square minus 9t minus of 12. Again, the degree is definitely not less than the degree of the divisor. We have to continue the process. Divide 3t cube with t square, we will get the answer as plus 3t. So plus 3t will get multiplied with whole of the terms of the divisors. So it would be 3t cube minus of 9t minus of 9t. So I'm writing it below 9t. So it is minus 3 plus 3t, minus is plus, so minus plus is negative obviously. So 3 into 3 is 9, so it is 9t. Again, we are taking the signs as negative and positive. Both of these terms get cancelled. At the end, what we are getting? We are getting 4t square minus of 12. Again, we have the degree, both of the degrees are equal to each other. So let's just divide the very first term again. So we have 4t square minus of 12. At the end, what we are getting? We are getting the remainder as nothing but is equal to 0. Whenever the remainder is definitely is equal to 0, it means that the GT is nothing but a factor of PT. So what we can say, by division algorithm, what we can say? We can say that PT is totally divisible by GT, because it can be represented as GT into of QT plus of RT. So where the remainder is coming out to be is equal to 0. So we can represent it as PT is equal to G of T into Q of T. At the end, we can write it as 2t raised to the power 4 plus 3t cube minus 2t square minus of 9t minus of 12 can be represented as t square minus of 3 into 2t square plus 3t plus of 4. And both of these are nothing but the factors of this particular polynomial. So at the end, what we can say? We can say that yes, t square minus 3 is a factor of the polynomial PT. So this is nothing but our answer.